So on Monday, the 22nd of February, you guys will be able to multiply polynomial section 6.6. Heads up, we're doing our last section of this chapter on Wednesday, meaning we're reviewing on Friday for our test next Tuesday. So test a week from tomorrow, okay? Does that make sense? What are we reviewing for the review? There's no review for the review, it's just a review.
What are we doing for the review?
Oh, what do you think? Probably basketball. Oh, maybe. I still need to think more about that. You're right.
We can help you make it.
All right.
You have to come up with equations, but we
Yeah, could be good. All right. Let's look up here, guys. Multiplication of polynomials. So, we're going to use that distributive property. So, do you guys remember doing like 2 times the quantity of 3x plus 2? Remember what we would do in that? Okay, we distribute the 2, right? And so, you'd have 2 times 3x and get 6x. 2 times 2 and get 4, right? And we said we can't combine those, so we're done, aren't we? Okay. Does that sound familiar to anybody?
Yes.
Okay. So we're going to start kind of with that same thing, but instead of having a 2 out there, we're going to have a negative 6t with the variable, okay? But still going to do that same idea here with distributing. So we're going to say, okay, what's negative 6t times 5t? Okay. Negative 30 t what? Squared. Remember, when we're multiplying variables, you add the exponents. And so this is like a t to the first and a t to the first. So it becomes t to the second, or t squared. And then we do negative 6t times 2, and what's that going to be? Negative 12t. Very good. Now, can we combine these? No, we can't. They'd have different exponents. So we're done there. Questions on that? Okay. Let's look at the second example. Here, the 2x is going to distribute. What is the 2x going to distribute to, though?
5x, because everything.
Oh, there we go. Everything in the parentheses, okay? It's not going to distribute after the parentheses. It's only going to distribute to everything in the parentheses there, okay? So let's start off here with 2x times 3x squared. What's that going to be?
6x.
Very good. 6x cubed, or 6x to the third, okay? 1 plus 2 on those exponents. 2x times 5x is going to give us what? 10x squared. Very good. And then 2x times 2 plus 4x. Very good. Now we just rewrite that plus 2x plus 4. Those were just chilling there. Now here, is there stuff we can still combine?
Yes.
Yeah, so we need to do that still. So that 6x to the third is coming first, that 10x squared is coming second, 4x, and the 2x are coming third, and that 4 coming out at the end. We might notice it's actually still in the right order. We just need to combine those x's, right? Okay, so 6x cubed plus 10x squared, I heard it, plus 6x plus 4. That's going to be our answer. I think so too. Any question on this, guys?
The next one can't.
This next one. Now we're doing some subtraction, aren't we? Now remember, I said the first thing we want to do is change signs, but actually I'm going to give us a pause on this one, okay? For changing signs. I'm going to show you why we're going to do this one a little bit differently than the other one, but it's going to end up working out very much the same as far as the negative going into everything. We're going to start off with distributing this 3b to everything. So what would 3b times 2a squared be?
3ab cubed.
Okay, not quite. So it's going to be 6. Okay, which one's squared, the a or the b? Okay, you either do ba squared, I'll do a squared b just so it's alphabetical. But the a is before the b's. But the squared staying on the a, the b is staying to the first power, okay? Questions on that? Very good. Very good. 12ab squared, okay? 3 times 4 is 12. A times no other a over here is just a. And b times b is b squared. We add those exponents. 3b times 2, 6b. Now, when I'm changing the sign here, here's what I'm going to do. I'm just going to change the a. So I'm going to make this a positive and make this I'm adding a negative a. Because watch what's going to happen as we distribute in this negative a. Negative a times positive 4ab is going to give us what? Okay, negative 4a squared b. Negative a times positive 2b squared is going to give us what? Negative 2ab squared. Negative a times 4. Negative 4a. So, what ended up happening with these three signs at the end? Did the signs stay the same, or did they stay the same, or did they change? They change. Now, whenever we have the subtraction, we always change those signs anyway, right? So because we just changed this a outside of the parenthesis, and then we distributed the a, it ended up changing all of the signs. Does that make sense or no? Be honest with me, does that make sense or no?
Yeah.
Okay, someone's saying yes, someone's saying no, okay. So here, a lot of times on like our previous one, the homework we just got finished with, when we had, let me even go back to the warm-up here. When we had this negative subtracting, we changed all the signs after. Here, just by changing this a and then distributing that in, all of these three positives turn to the opposite sign, being three negatives. So it actually takes care of it for us when we end up distributing this. So it ends up being very similar. Now from here, we need to combine like terms and make sure we have our order correct. What's going to come first out of everything here? Okay, very good. Those a squared b. So we have a 6a squared b and a negative 4a squared b. What's going to come second?
AB squared.
Yeah, those ab squareds are going to come second. Very good. The 12ab squared and the negative 2ab squared. What's coming third?
Negative 4a.
Very good. And what's coming last?
6b.
Very good. So now we have the 1 underlined. 6 and a negative 4 gives us what?
2 and 2 squared b.
Very good. 2a squared b. Reminder, when we add and subtract these, the exponents and variables are not changing, okay? 2 underlines, 12 and a negative 2, ab squared. So plus 10 ab squared. 3 underlines, negative 4a is by itself. And then 6 underlines, that plus 6b is by itself. We have everything combined, everything in the right order. And it's done. Questions on that or no? Okay. I want you guys to try number 4 on your own. When you have it or have questions, raise your hand. And as I looked around on some of these guys, some of us had an issue a couple times with making sure our exponents were the correct exponents at the end. So if it's helpful, write in a little 1 there so you know this is y to the first, and then go through and add 1 plus 2 is 3. And say, okay, well, for the next one, 4y times 3y, that's 12y squared, and just add up this 1 plus 1 and give us 2, okay? If that's helpful for you, go ahead and do that. Thank you.
And the rings on my alphabet as well.
Oh, thank you. 4y times negative 5 is negative 20y. And then with that negative y squared, that minus y squared, I'm going to change this to adding a negative y squared, just like we did in the last one, and now distribute that. So negative y squared times a positive y. Once again, if you're writing this in there, the exponent's going to help, then do that. And call this negative y to the third. Negative y squared times negative 3 is positive 3y squared. All right, now let's go through and underline. So 8y to the third and negative y to the third come first. 12y squared and 3y squared come second, and that negative 20y comes third. See me? 8 minus 1 is a 7y to the third. 12 and a 3 gives us 15y squared minus 20y. Any questions on this one at all? Okay. How are you guys feeling about this so far? Okay. Okay. All right, let's go ahead and go on to the next page here. I'm going to have a skip number 5 today. Okay? Ooh, alrighty. Anyone that's already done it, I'll give you the answer real quick just so you can check it. X to the fourth plus 14x to the third minus 8x squared plus 16x. So if you did that already and you got that one right, hey, good job. Slap on the back. All right, on these equations, okay, notice we have an equal sign here. So we're going to go through this and solve very, very similar to what we've been doing, okay? We're going to still distribute the x as we work left to right here, okay? So x times x is what? X squared, very good. X times negative 2 is negative 2x. And we still have that plus 7x over there. Now I'm going to write that equal sign. And I'm going to do everything on the right side of the equal sign now too. X times 4, 4x. And x times x, yep, is x squared. Nailed it. We still have that minus 9x plus 14. Now when I'm going through this and I'm going to underline, I'm going to deal with the left side separately from the right side, okay? So the left side, everything's actually in order, but we do need to combine that negative 2x and the 7x. So it's going to be x squared plus 5x. Very good. On the right-hand side, x squared comes first, that 4x comes second, and the negative 9x comes second, and that 14 comes at the end. Notice we're dealing with this separately because they're on different sides of the equal sign here. So x squared, 4 minus 9 is going to be a negative 5x plus 14. We will end up getting x is equal to a number here. Question on how we got this far, though. Alrighty. Now for this part, we have x squared. That's new to us, right? We haven't seen those yet. Like x squared is in an equation. We haven't had that. What we're going to do is we're going to do something very similar to what we do with our x's. What do we like to do with our normal x's? Get them by themselves and get them all together, right? Well, let's do the same thing with these x squareds. Let's say I want to move this x squared over here. How would I move it? Subtract it. So I'm going to subtract an x squared. Now what's x squared minus itself? Nothing. It's 0. I have to do it to the other side, and x squared minus itself is also 0. So do we have any more x squareds to worry about? No, they ended up zeroing out, which is kind of convenient for us. So we have 5x equal to negative 5x plus 14. Now, does this look like a lot more normal of an equation for us? I'd say so. Okay. So what would we do at this point? Okay. So we'd add 5x to both sides. Move the negative one over to the left. So 10x is equal to 14. Now you might notice we're kind of destined to get a fraction here, right? As we take 10x is equal to 14 and we do what to it? Divide by 10. Very good. And x is equal to 14 over 10. Does that simplify at all?
Yes, that's really simple.
Yeah, 2 goes into both of them and it becomes 7 over 5. And that's our answer. It's okay for us to leave it as a fraction if you want. Decimal would be 1.4. Base number would be 1 2/5. Was that... I mean, the one new part of the math here was probably those x squareds, but that ended up kind of working itself out, didn't it? Okay. Let's go and try number 2 here as well, okay? So number 2, are we going to handle this pretty well the same way? Yeah, even though there's a's, it's going to be very similar. So as we distribute the a, we get a squared minus 4a plus 5a plus 2. Then we distribute the a on the other side. A times a is a squared. A times 2 is 2a minus 2a plus 9. Then we're going to go through and combine like terms. Any questions on how I got here, though? Alrighty. So a squared is going first, negative 4a, and the 5a are going second, and that 2 is going last. I'm going to stop there on the left-hand side and not go on to the right-hand side yet. So the a squared is going to be a squared. Negative 4a plus 5a is just plus a plus 2 equals, well, now I'm going to do the right-hand side. A squared comes first, 2a and negative 2a comes second, and that 9 comes last. What do we notice about 2a and negative 2a? Yeah, they go to 0, right? So we don't have to write it. We have a squared plus 9. Pretty similar spot to where we were on the last problem. What did we do before? Yeah, we move the a squared by subtracting it from both sides. Now what's going to happen on both sides here, though? It's going to zero out, right? So we're just left with a plus 2 equals 9. And subtract 2, very good. A is 7. And that one worked out a little bit nicer than the previous one, didn't it? Yeah. Let me pause a second there for anyone to catch up if you need and ask any questions you might have.
I'm feeling pretty good.
Alrighty, happy to hear it. Feeling pretty good. I'm Mr. Cossel.
I'm doing the mom cardigan thing.
Oh, yes, yes.
The mom cardigan thing was really good.
I feel that.
Yeah, the zip is gone. I don't know where it went.
Oh, that's a rip.
It was probably in the washing machine.
Movie has to sit in Narnia now.
I wish I was
Go find it from the Lion, the Witch, and the Wardrobe somewhere.
Abby would be the people with the goat feet.
What?
When they, like,
What's that
walk
even mean?
around. Have you seen that? They have like half of their bodies they can wear and then they have to be the goat. I would go.
Like, are you talking about like mythical creatures?
Yeah.
Oh, for Narnia. Okay, sorry. I feel ya. Alright, a little harsh, but okay. Alright, guys. So here's what's going to happen in our next part of these notes, okay? So we're going to multiply a binomial times a binomial. Binomial is 2. Remember, bi prefix is 2, like bicycle. Okay. So for polynomials, we're going to use the distributive property more than once. So when we have x plus 2 times the quantity of x minus 4, we're going to say, okay, I'm going to take this first thing, x, in the first parenthesis, and I'm not multiplying with the 2 because they're adding, but I'm going to multiply x to everything in the next parenthesis. So it's going to be x times x, which is x squared. And I'm going to do x to the next thing over there, that negative 4. Negative 4x. Now I took this first thing, x, times everything in that next parenthesis. So I'm going to do the same thing with the next thing in this parenthesis, 2. And take the 2 times both of those. And do 2 times x, 2x, and the 2 times the negative 4, negative 8. And you might notice that we have some things that we can combine here. That negative 4x and the 2x can combine and become a negative 2x. So it's x squared minus 2x minus 8. Now, this is probably new to us, okay? So there's a couple different ways we can think about what just happened here, okay? So we can say, hey, in order to, because we had multiplication between these two parentheses, we had to do every combination together, okay? I put it away. Okay, we had to do every single combination together. So x times both of these things, 2 times both of these things, and we ended up getting every single combination possible between those 4 that are multiplying, except for x times 2 because they're adding, and x times negative 4 because they're subtracting. Okay, so you wouldn't add and subtract, or you wouldn't multiply those because they're adding and subtracting. We have this acronym FOIL that helps us remember what we do when we multiply a binomial times a binomial, which is what just happened here, okay? Has anyone ever heard of FOIL before? Okay, Emily, you have? Okay, Raquel, you have? Okay, are you just talking about aluminum foil?
No, I'm talking
Okay.
about like English. Like literary.
I don't know the English literary foil.
It's for like drama or whatever.
Oh, neat.
That's what it was.
Right?
The bad guy. It's the opposite of the same time. Same thing. You can't.
Oh, okay.
Oh, and it requires the character to grow.
Okay. Oh, gotcha. Emily, is that where you're talking about too, or no? You're talking about the math one? Okay. Do you know what the math one is, Emily? Do you know what the acronym stands for?
Isn't it first, outer, inner, last?
Yeah. So the first, the F stands for first, saying the first thing in each parentheses. So x is the first thing in this first parenthesis, and x is the first thing in this parenthesis. So it's x times x. The first multiplied together gives us x squared. O, however you want to word that, outer or outsides. I always say outsides. Either way, it's the same thing. So the outside of this. So the outside on the left is x. The outside on the right side is negative 4. So x times negative 4 is negative 4x. The opposite of insides is, the opposite of outsides is insides. You gotta love that when the teacher says the answer to their question. The insides here are going to be this 2 and the x because they're on the inside of these parentheses here. They're together. So 2 times x is 2x. And the opposite of first is last. So the last thing in the parentheses are 2 and -4, so it's 2 times -4, -8. And so that can be a helpful way to remember these. Some people really latch onto this and use this to remember, and other people just honestly don't find it useful, and that's okay either way. I just want to give you guys tools to help remember it and say, hey, use what you want, but here's kind of your base toolbox, so to speak, okay? Any questions on that? All right. Let's practice this, okay? So on number 1, we have 2 binomials. So let's think of this as FOIL, okay? Like I said, we can think about it a couple different ways. We're going to think about it as FOIL. So we're going to multiply the first things together. So what are the first things together in this? X and x. So that's going to be x squared. Now we're going to do the outsides, okay? We're going to do the outsides. So what's the outside of each parenthesis here? X and 9. That's going to give us what? 9x. Now we're going to do the insides. So what are the inside two? -4 and x, so that gives us -4x. And what are the last of each parenthesis? -4 and 9, so that gives us what? -36. Depends on what you're talking about, yeah? Could be. All right. If you're saying somebody scored 36 points, it's a big number. If you're saying it's 36 degrees outside, not a big number.
Actually, the other
So you scored 36 points?
on Saturday it was 27 degrees, and I went outside in a short sleeve t-shirt with no jacket on, and it was perfect.
All right. Feels good after we had negative temps.
I took Tiliano more.
All right. Ooh, nice. So we might notice here, it's already in order, but do we have things to combine? Yeah, and it might be good for us just to stay in the habit of underlining, just to make sure we stay in the right order. And in case some problems are not in the right order, we can get them there. So x squared, what's 9x minus 4x?
5x.
Plus 5x. And minus 36. So that's our answer. Questions on that at all? So we thought of that first one as FOIL. Okay, I want to think of this one, second one, kind of the way we did that first example before these, even before we went over FOIL. So I'm just going to say everything in the first parenthesis times everything in the last. So I'm just going to start with the very first thing we see, the A, and I'm going to multiply it to everything in that second parenthesis. So A times 2A, 2A to the second. A times 4, 4A. Now I did A times everything in this next parenthesis. We've kind of exhausted A, so to speak. So now let's do this 5, the next thing, everything in the next parenthesis. So 10A and 20. So whether or not you think of it as FOIL, or everything in the first times everything in the second, or another way, as long as you're still multiplying everything together, you're doing it correctly. So here, 2A squared is going to come first, followed by the 4A and 10A, followed by 20. So what's 2A squared staying the same? What's 4A plus 10A? 14A. And then plus that 20 at the end. Questions on that? All right, I want you guys to try number 3. When you have number 3 or have questions, raise your hand. So on this one, y times y is y squared. Y times -8 is -8y. 8 times y is 8y. Raquel, please face forward. 8 times -8 is -64. Here, when we combine like terms, we might notice that those -8y and 8y do what? They go to 0. So we end up just getting us y squared minus 64 as our answer. That's kind of handy. That'll kind of went away. Any questions on number 3? Okay. Give me a thumbs up if you're feeling good about these, thumbs down if you're not. I want everyone to give me your reaction, even if it's very private and close to your chest, okay? Alrighty. We're going to skip number 4 here. And we're going to go on to number 5. Number 5, what's different? There's 3 in the second one, right? It's a trinomial, right? Very good, very good. Now, for this trinomial, okay, a lot of things are still going to be very similar. Now, FOIL quite won't work, right? Because there's more than 4 different things going on here. So FOIL won't work anymore necessarily, but it's still going to be the same idea, okay? So we're going to still do everything in the first times everything in that second. So it's still going to be 2y times 3y squared times 4y, but also to that 5, okay? So let's walk through that. 2y times 3y squared is going to be 6y to the third. 2y times 4y is going to be 8y to the second. And then 2y times 5, 10y. So now I did 2y times absolutely everything in that next parenthesis. So what am I going to do next? Do the same thing with the 5. Multiply to those 3 in the following parentheses. So 5 times 3y squared, 15y to the second. 5 times 4y, 20y. And then 5 times 5, ha ha ha. All right, from here, combining like terms, 6y to the third comes first. What comes second? 8y to the second. What else? And 15y to the second. What's coming third?
20y.
Okay, 20y and 10y. And that 25 ha 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 is coming last. All right, so 6y to the third is by itself. Then 2 underlines 8 plus 15 is what? Plus 23y squared. Then we have plus 10y plus 20y gives us what? 30y. Plus that 25, ha ha ha.
I wanted to do it
Ah. Any?
1, 2, 3.
Oh, I thought we were just saying 25. Sorry, let's do this again.
Okay. 1, 2, 3.
Ha ha ha. It's in stereo now. All right. Any questions on number 5? Okay, so it just kind of got bigger from before, right? But we're really kind of still doing that same thing. Well, what's different here on number 6? Okay, there's 2 trinomials, right? So we're going to do the same kind of thing, though, right? We're going to still go through with the x squared, with the x. But what are we going to have to do after we do those first 2? Same thing with the 5, okay? So heads up, you're going to have a lot to write here, okay? On this one, we ended up having 6 things. We're going to have 9 things here. Okay, so it's going to get very big very quickly as far as a lot to write. So let's start with x squared times 3x squared, 3x to the 4th. X squared times 2x, 2x to the 3rd. Then x squared times 5 plus 5x squared. Next we have this x times 3x squared. I'm going to do different colors on this one just to make it pop easier because we have a lot going on. Plus 3x to the 3rd. X times 2x, 2x squared. X times 5, 5x. All right, then we have the 5 times everything. 5 times 3x squared plus 15x squared. Now you might notice I'm kind of running out of room here, right? And you guys might be as well. So what you can do in this scenario, 5 times 2x, is you can just write it beneath it if you need to. It's obviously not ideal, but sometimes you just got to do what you got to do. 5 times 5 plus 25, ha ha ha. Sorry, Cal, do you want to join me on that one? Plus 25, ha ha ha. Perfect. Questions on how we got here. Okay, now we still have to go through and do our underlines and combining like terms and everything like that, okay? So the 3x to the 4th is going to come first. How many x to the 3rds do we have coming second? 2. How many x squareds do we have coming third? 3 of them. And how many x's do we have coming fourth? 2 again. And then our funniest numbers there at the end, 5. All right. So now we have our first thing, so 3x to the fourth. Our second thing, we have a 2 and a 3. That gives us 5. Very good, 5x to the third. Now we look for 3 underlines. What's 5 plus 2 plus 15? 22x to the second. Very good. Taylor Swift would be pretty happy about that. Then, I really like this crossing out, especially on these kind of problems, because then we can see, okay, taken care of, taken care of, taken care of, taken care of, taken care of. Oh, we still have 5x. We still have 10x. That's going to give us what? 15x. And then our last funny number here, 25. Ha ha ha. Questions on that? Now you might be wondering, okay, especially when we get to our homework, guys, there's going to be a problem where it's going to have something like this. Either way. Oh, I heard it. What was that, Eli? Just do an order. Like, we're just going to do the first two, kind of ignore the third one exists for a moment, and then simplify the first two, and then now multiply it to the third one, okay? Just like if we were to do this. You do the first two, 3 times 4 is 12, and then do that with the 5 and call it 60. Does that sound familiar to us? Have we done stuff like that before? Yeah, but it's just kind of new that we see 3 binomials. Same idea though. Just do the first two, and then kind of do it with the last one once you're done with the first two. Great question, okay? Can we just keep going through and say x times this, times this, times this, this times this, times this, times this? And actually the answer is no. It won't work to be the same, unfortunately. Because what you'd be missing out then is you're missing out this x times x and the x times 2 and the 3 times x and the 3 times 2. And so it gets even messier. Because you're missing out on those if you just go all the way across. So it's best for us just to do it to the first two parentheses and then pause, regroup, and then go from there. Great question, Raquel.
With everyone that has 3 parentheses.
Yep. Alrighty. Any other questions before we get to our homework?